Hello YouTube, friends, subscribers, jwsolarusa. This is what I have here. This is the setup is coming to play. Keep adding up stuff as I go with the series of the videos, and you can see the next time you're gonna see probably the solar panels hooking up to the batteries, and you have the refrigerator is gonna be there, and it's gonna be a full operational mode. So YouTube, this is what we're gonna be dealing with here. Is a Chefmate refrigerator, just a little one right here. And if you guys watch the part 1 of the video, you will see exactly what I'm dealing with. Portable system, beautiful. Most of these little refrigerators, they normally use on little offices, or maybe a student from college, you know, they have all these little things that just to keep their food and little snacks. And sometimes they have hospitals, like people that has medical issues, they can put their like insulin and all medication, all that kind of cool stuff. Okay, so hold on, I'll give you guys the specs here. Okay, we're back again, YouTube. This is the Chefmate. Model number is BC as boy Charlie -15A. Well, I suppose you guys can see all the configurations. You see how this refrigerator is wired, the circuitry and all that stuff, and of course it made in China. Okay, you see that? This so is 110 volts AC, and frequency is 60 hertz, which is North America frequency, United States and all that stuff. And the rated current this thing is taking is just an amp. That's awesome, at 70 watt. So some people tend to look at the wattage, but the current you're drawing from your battery, I think that's what you have to really concern about. Okay, and remember folks, the battery right here is 88 amp hour battery bank, 4 12 volt 22 amp hour battery. Each of them is running for 20 hours, as the specs says on the battery. So the volume of this is a 0.58 cubic feet. Is a 16 liter. This is a 2008. The manufacturer 2008. There's a serial number right there if you want to check it out online, and you can see exactly the specs of this thing. So folks, this refrigerator just passed is 8 years old. It's really old, and look at that, it's still efficient, taking only an amp at 70 watts. If you look at it in just a normal life, you know, my big house refrigerator is taking 79 watts, which is I can look at this one like it's not much efficient. But drawing only an amp, you know, that's not bad for just emergency thing. And if you have the sun outside, you can able to go for hours and hours and hours. You can even drain this battery easily. Okay, so here is the, you know, the fan. It is a filter that's supposed to protect dust and all other debris to come in, because the fan draws the intake is from here, circulating, cooling the system. So if you can see the specs right there, it has a LED inside. So it has 4 feet it stands on, and it has a water drainage system here, when it's condensing, you know, thawing out, the water sits right there instead of dripping all over your carpet. So far so good, YouTube, and I'm just gonna get into the process here and get this baby working. All right, stay tuned. Okay, YouTube, now I have all the wire connected, and I just want to show you guys how this thing, I'm gonna turn this inverter on. Let's keep fingers crossed again and make sure everything is working. You know, let's give a countdown. 3, 2, 1. Fire it up. Ha! Look at that. The LED's on. It's running. You know, I'll stop this one right away, YouTube, because so that you guys I can able to put it on how you call it, a kilowatt. Then you guys can see exactly how many watts this thing is taking, if it's true according to the specs. I forgot totally. I was gonna just give up. I'm so excited to show you guys. So I'll stop the video from here and grab the kilowatt meter. All right, YouTube, I already have the kilowatt meters already hooked up to the system, to the Samlex Power 350 watts inverter, and I'm gonna plug this device right here to right here, and we can see the power. But before doing that, I would like to show you if what the wattage and the voltage supposed to show on this one, how much this device can draw at a surge or on a normal run. Okay, and let's see what's the voltage was right through with my multimeter. And now we're gonna use the kilowatt. Well, according to the kilowatt, it's showing that is 118.7. It's very close. It's really close. See that? So we can able to, I don't know, because of the component or the circuitry, what are the little capacitor resistors or transistors built in into that thing. I don't know if they have that, but we can check the hertz and see. You see, that's 59.6. It's almost clean, you know. So that's the amps right there. So we're gonna plug this thing. Let's go back to the watt, volt. Okay, the watts right there. Stay tuned and see how much load this thing's gonna take at a surge. All right, YouTube, this is how we're gonna do right now. Take a look, and I'm gonna plug the refrigerator Chefmate into the system and see how much power we're drawing. You guys can see I'll crank it up here, the cold. Alright, YouTube, as you can hear, I just turned the device on. The power indicator is there. It's drawing 58.2 watts, and the fan, you can hear it, it's running. And here's the fan. Oh yeah, look at that. So it has a nice little LED right there at the bottom. And the fan is going fast, if you guys can see, and if you can hear it, but everything seems to be pretty good. And I'm gonna do some quick tests here, if you guys don't mind. Hold on. Alright, YouTube, I have a meter here. It's a precision inside, indoors, outdoor from Radio Shack. It has in and out. So I'm gonna put this probe right here into the refrigerator, and we can see exactly what's the temperature the thing is gonna be showing. Okay, so we're gonna use it just as for outdoor right now. Look, it's reading at 80.2. And now pop the refrigerator. I'm gonna put this device right here. Hope you guys can bear with me because the cold flows underneath from here. So I'm gonna be hanging this device to see how cold this device is gonna do for us. So as they say, cold air, it condenses, hot air rises. So I put it right there. Remember, it was 80 point something. So I gotta have these probe temperature thing. Stay right there, buddy. Stay there. Okay, so we're gonna try it this way and see. Look at the temperature right now. It was 80.3, I suppose. You guys saw that on the video. And now it's dropping to 78.6. Okay. Alright, YouTube, I just dropped the closed the refrigerator right there, and everything is running, and the meter is reading 56.8 watts coming out. So let's check the amps. So it's only pulling 0.82 amps. So it's a 800 milliamp. It's not even an amp. So the specs was saying was an amp on this refrigerator. I can show you from the back again if you don't mind. Alright folks, you see that? It says current out. The rated current is an amp. It's 70 watts. And it's not even pulling at 70 watts. It's pulling 58 watt. So right now is on high. And folks, this is just a recap again. It's a Chefmate BC-515A. So it's a 2008. It's not like the latest technology right here. But it's 110 volts. It's doing pretty good. Everything looks awesome. Let's check the meter again and see for the temperature. And as we check the volt coming in from the inverter as well. Alright, and after that I'll show you the voltage on the batteries, how they handle stuff. Okay, alright, back again folks. You can see how the back again folks, you can see, well, the meter just started running, and it's dropping to 70.8 from 80.2. Look at that, it's almost dropping about 10 degrees now. It's getting there. It's about 8 degrees Fahrenheit already dropped. So we pull in that 800 milliamp. So it's not even an amp. Okay, you can hear the inverter because it has the load sensing. When you put load from it, that time it started drawing, the fan kicks in a higher RPM. So this is the 117.3 volt. So let's check. So 59 hertz. Okay, see that? 59 hertz. The HTZ right there. So it's almost 60 hertz. I think it's a really clear sine, pure sine wave. Right now that's the alright, Let's see. Okay, amps. That's the watts. It's drawing 56.4 for 5, 6, 7. It's going up, so it's doing really good. And look at that, 69.7. It's getting colder inside. So let's put this one for inside. I can show you the temperature in the room. Let's see, probably it's gonna take a while. See, this is the inside temperature, because I'm sitting by the door, so it looks like the wind, the breeze is blowing, so keep it kind of a little bit cooler. But let's put it back inside. Let's say the outs, because we have the sensor set up for outside, for the inside of here. It's dropping. It's still in good shape, so I'm gonna give you some readings here pretty quick on the batteries. Oh yeah, it's getting cold. It's getting cold, folks. This thing is working. It's getting cold. I like that. So these are the things that you always pray for. You want to do a project that turned out pretty good. So just by opening the door, temperature increased again, because we already took some hot air into it. Right now it went back to 70.8. I'll give you some readings here on the batteries. Alright folks, the batteries, that's the voltage right now. It's a 12.66 volt from the batteries. So the batteries are holding up pretty good. And here's the temperature, the inside of the refrigerator. So it's still running. Okay, everything looks pretty good. I'm surprised at the batteries. So far so good. The system is holding up pretty good. And the fuse right there is doing its thing. And the batteries are sitting there just like I'm fine. Alright folks, it's a 56 watt, and it's dropping gradually. And that's the amps right there, and that's the watt. And I can able to show you the time we started running this device. Let me see a time lapse here. All right, maybe I missed that. All the voltage is still steady, 117 as I speak, and you see 59.6 hertz. It's just about 56.3. Okay, system is running pretty good. It's drawing only 800 milliamp. It's not even an amp. All right, this is a good test for you guys. I just want to tell you, anything that you set your mind into, and don't let nobody tell you you can't do this. Let nobody dictate for you. Nobody tell you that, oh yeah, solar doesn't work. It's a lie, scam, all that kind of stuff. You know, don't listen to them. You know, ask them if they have a system. Say, do you have a system? You know how to do this? Let me tell you something. These guys, there are guys out there who tend to read everything and understand it. They understand it, but they don't have no channel. They don't even have no video up. But they're trying to tell you that you're wrong. Oh, this is not the thing. They always are the one telling you what to do, what to say. And check them out. If you look up, nothing. They don't have no video. They don't have no channel. They have a channel. They don't have no video. Nothing. They just feature other people's videos. That's all they do, because they want the subscribers. But it's not happening. You know, believe yourself and do what you gotta do. and make sure you do it right. So this is a one old setup I have here for you. If you're a beginner, a new guy, or whatever, you get into solar, this is a one old video to inspire you how to do solar. So we are running, remember, 56 watt this thing is taking, and it's 350 watt. You can make it up to 350. The system is going to shut down. Sometimes it peaks all the way up there. So my next step, I'm going to be plugging the freezer into this one and see what we're going to do. Alright, take care folks, and please subscribe and thumbs up. Bye for now. Alright folks, just gonna wrap up this video. This is the final, and I'm gonna stop there because I want to try the chest freezer. So the temperature is dropping gradually to 66 degrees F. Okay, see that? Fahrenheit. So for you guys or folks in overseas, you can just convert this one. You know how cold it is. Alright, so system has been running approximately 10 minutes now, 10 to 15 minutes, and we're still holding into that wattage. They said it's 70. We never hit that 70, and they said it's an amp. We never reached that amp, so we're still sitting at 0.82 amps. Very, very, very efficient. Alright, well, this is the thing, and 65.7 temperature in the refrigerator. Batteries are awesome, doing pretty good, and the fan is running on the inverter. Alright, take care. I'm gonna be testing the big guy here. You have a pleasant day, and God bless. Bye bye. Alright YouTube, the jwsolarusa right here, and we're gonna be trying this Samlex 350 watt Pure Sine Wave Inverter. The Samlex Power 350. So I'm gonna be trying this extension cord going to my 60 inches ultra high definition smart TV, if this inverter can power it. Okay, there we go. We got some readings there. 119.5. The fan just kicked in, so we're gonna set it up on watt and see. Well, this will be part 8 if everything goes well with the system, and you guys will see exactly what I'm talking about here, live from Minnesota, jwsolarusa, and I'll bring you this video so that you guys can able to see really if it really worth it for me to, if there is a crisis, if I can able to utilize this inverter for emergency purposes. Alright, so we will see. I'll let my wife turn the power for the TV. See right there, kicks in 25 watt. Oh, you see that surge? It went up to about 99. Well, now the TV is on. The fan is cranking, so it drops from 99 to 49.2 watt. So let's see what's the amps is drawing. It's almost 400 milliamp. It's not even half an amp. 400 milliamp. So folks, this thing can power me on emergency situation. We can able to watch television here, but I don't want my video to be a copyright. Well, I'll see what channel I'm gonna get into, and folks, stay tuned and I'll show you the television right here.